All right, we're going to have a look here at isometrics. Talk about this a little bit. So here we have a top view, or plan view. Now that doesn't do you a whole lot of good, but this is to understand isometrics, but this is generally what you're going to get on a set of blueprints for a building. Don't matter what trade you're in. So it's your top view looking down. All right, and then if you look at it, we'll look at it from a south elevation. Whoops, we should probably settle that there. South elevation would be an elevation view. So the bottom of this building, this cube, and then you've got the top of it. So between the top and the bottom, you have a change in elevation, therefore it's called an elevation view. So this would be the south elevation view. Then if you rotate it, now we're underground here, so you know there's the bottom, but now here's the east view. So east elevation. And of course, you know, you've got your north and west and this and that and the other. So why would we need to know how to do something isometrically, and what is an isometric view? An isometric view is like this. So you got your plan view, you got your elevation, and you have a right side. Well, what if we could put everything from this view, and this view into one view? Well, you can. What you do, you take your building and you rotate it at a 45-degree angle with the degrees of the compass. And then you rotate it up 45 degrees. Whoops. If your computer program will cooperate. Pretty touchy here. So then if you look at that, this is almost an isometric drawing. Problem is with this picture, it's actually a 3D drawing, and 3D is not the same as isometric. So this is a true three-dimensional representation on a two-dimensional plane, and the difference between this view, and which is 3D, and an isometric view is an isometric view, the vertical lines will be the same length. But when you start rotating things in a true three-dimensional view, notice that vertical line shorter. So, you know, at 45 degrees like this, it's actually a little bit shorter than it is on your elevation. So there'll be some slight differences, but it gives you a good approximation, makes it much easier to draw. I'm sure there's somebody with a formula somewhere that could tell you how to do it three-dimensional, but for what we're doing, isometric works perfect. Your brain sees it, it works, and the whole purpose of isometric is to save you time, and time is money. So the line at the bottom of the block on the east side of the block, the red side if you're not colorblind, goes up and to the right. So starting at the bottom center of the block, center of the screen, it goes up and to the right at approximately, in this picture everything's approximate, but we're going to say it's not approximate. It goes up and to the right at a 60-degree angle. Start back at the bottom center. It goes up and to the left along the bottom of the south side at a 60-degree angle. The vertical line is vertical. Like I said, if that line was, say 2 inches on your print vertically, then you would still draw it here, but because we're rotating it and it's 3D, it's not quite two-dimensional. But when you draw it, you will put the same dimensions on your lines. And it goes the same for your lines going east and your lines going west, whichever way, east, west, north, south. They'll be the same, and it'll make sense to you when you start to draw on get you some isometric paper and just scale things out. So what view would this be? So this would be a top view from the southeast side. Now you got a bottom from the southeast. Now what do we say here? Generally we're going to name either north or south first, right? So we're going to say northeast bottom, northeast top, northwest top, northwest bottom, and we've got a southwest bottom view and a southwest top view. Notice there are 8 different corners to a square. Those are called vertices. Anywhere on a shape where lines intersect is a vertex. So vertices are more than one. So we've got 8 different corners, so you could have 8 different views. Generally we get a set of prints like this. Maybe you get an elevation, and maybe they'll cut through the thing, and you might get a another or second elevation. And let's see if I'm able to do this here. If I take and I split this, now I can split this in half. And you can look inside of it. Sometimes when you see split lines on a building, that's what they're doing, is they'll split things open for you. And then you get an interior view of a building. So if you see a couple little lines on your blueprint, that they'll have little arrows in the middle of an elevation view, and they're pointing to the right or the left. If they're pointing to the right, that means you're going to be standing on the left side looking in. So pretty neat little thing to know about that. But there's your, you know, you could call it a split plane view, or you could call it a sectional view of a set of prints. A couple different names, but that's what that's all about. And see, that's the difference. There's your building, so you know you can't see anything when you're looking around like that. So for clarity's sake, sometimes they do stuff like that. And you know, you could even have a split bottom view, I suppose, which would be kind of odd. I've never seen that done before, but like I said, you could do something like that, and then turn around and you get your elevation view halfway down the building because maybe you've got some stuff in your way. So anyway, what does all this have to do with anything? Well, okay, what if there was something inside that building and you wanted to draw it looking up like that? Now this is kind of hard to see, so let's try something a little bit different here and look at a separate building, and we'll see if we can't do something with it. So here's your building. Now this is, again, this is a three-dimensional view, so it's not going to be true isometric. So here we have a building, standard three-story office building. A lot of you may build some of these in your life. You know, how long would it take to build a building like this? 3 stories, open interior, something like a library. Well, something to talk about among yourselves. So here's your front elevation view. Looks fairly square and rectangular. And if we get it right down in front of us, because it is a 3-story building, it's making it a little different because it's in 3-dimensional. So here's your, what view is this called? So that would be your front elevation. I'm going to say your right side elevation. Notice because it's 3-dimension how your lines going up and down the side of the building are not straight there, so we've got some tapering going on to make it 3D. Now here's your right side elevation view. So we'll flip it back around here. And we've got your plan view. Now your plan view, that looks like a regular rectangular shaped building. Looks great. Now, if you do this, this is what they're calling an isometric left-hand view, which I don't know really why they would call it that. This would be to the right. So we're going to say this is a right isometric view because I'm looking at it from the right side. But notice how the top left end is a little bit wider. The reason for that is because this is a 3-dimensional building. It's not a true isometric form, so don't let that get you confused. Now we'll show you what they call a military right view. Now that's closer to an isometric view right there, would be what they would look like. However, this right here is a Cavalier Style. This is what I would say 90% of the people that start drawing isometrics, they make a mistake like this. They'll do their up and to the right or up and to the left correctly, but then the ones the opposite corner, they'll make them horizontally across the page. Now if this was a car, your front fender, say if your headlights were on the right hand side of this building, well your front driver's side headlight would be about a foot in front of your passenger side. if you see that. Now this thing automatically corrects itself, so watch when I do this. The second I start to roll it towards you, it adjusts itself back because it knows it's messed up. So that right there, if you shouldn't have any horizontal lines ever on an isometric drawing unless you're doing something like a rolling offset. Sometimes you'll end up some horizontal lines, and your instructor can show you what that's about. And this right here is just another perspective, but look how the back of the building looks wider than the front of the building. In an isometric drawing, that will not be the case. So I'm just going to adjust this. Now it adjusted itself, and the back and the front of the building look a lot closer to the same dimension. In a true isometric drawing, they would be. So here we have a different type of, this is closer to an isometric view here, but really the way you do your isometric views, again, we have the top of the building. We can see where it's pivoting there in the center of the screen. I'll try to get this right for you. We have a top view. We have our front elevation. We go on our right side. And then if I want to do an isometric, what I do is I'll take that building, rotate it 45 degrees, rotate it 45 degrees. There is your isometric front right-hand side view. If this was the south side and this here was the east side, this would be a southeast view looking down, or top view. Southeast side bottom view. Now, why would we ever want to draw a bottom view like that? Well, what if you had some lines going underneath of these overhangs around this place, or maybe an antifreeze loop, and somebody had to put a little whoop-de-doo there, and a drain and a backflow and this and that and the other, and there's a bunch of stuff in the way. Well, you didn't want to walk over there. Maybe you're the superintendent, or you're the foreman, and you're working on something on the other side of the building. You just sketch out a building right quick. You put you a few lines around it, draw a quick isometric draw, and say, look, run the pipe over here 6 inches off the wall around, go up there. Or maybe you're just explaining to somebody where a sprinkler drains out or something, or a light switch. You can do a quick sketch of something like this and say, oh yeah, it's on the third level up there, or the second level in the middle by the 3 lights over in the corner, 6 inches off the wall right here. Draw this, sketch it out right quick. There's a circle. I used to run multiple crews on a giant, well, maybe not giant for you, but a place that had over 100, way over 100 sprinkler systems at it, and I was running 2 and 3 crews every day. The customer would give me jobs to do, and I would go out, job check, walk over, look at the place, measure it out, figure out what I have to do. I design my own sprinkler stuff, you know. I'd go over this, okay, you know, you figure out your hazard, your square footage, supply, all this stuff. So once I got all that figured out and I knew what my coverage, my sprinklers were going to be, I'd go dimension it all out, you know, measure everything up, set my heads and stuff, draw the drawing, send it off the office. They'd run it through the computer, get the hydraulic calculations. But as I sent them all the pipe measurements and the material lists and everything. So I did all of my own design except for pipe sizing. And then they'd put the pipe sizes on it. And sometimes they do the takeouts for me, and sometimes I do the takeouts and fab the stuff on site, put it back in. However, you know, the engineer's 100 miles away from the mill site we worked out, set, you know, 4 or 5 days a week, so they didn't come out and look. So my guys, they'd be working on one side of the mill, I'm over doing this design work. Well, rather than me draw 2 or 3 sets of blueprints, it was actually easier for me to draw a set of isometric drawings, and I could put all the information on one print for them and hand it to them, and I'd say, hey, go walk over there to this side of the building through the corner, and lo and behold, from the floor view, this may be what they'd see. Now, the top center right there in the corner, you've got the dark line going from the center of the picture to the right. There's one side of the building. So you're looking up at it like that. So right over here in the center of the photograph is you got your dark line going from center to right. So maybe your main's going up that wall, and then from above the right-hand side, long horizontal dark line where those windows are, maybe your branch lines are going from that side of the building over to the windows on the other side, ever, 15 feet or something across. Well, it's pretty easy to sketch that. I don't have to give you an elevation view and a plan view, and I could draw my riser going down in the corner of that building over there, down to that gray floor in the corner, and whipping around a column or whatever, and throwing an FDC outside. And I would draw it from the bottom perspective, because when the guys walk into the building, that's what they're going to be looking at. Just think about that for a second. Same thing right here. Let's back up a little bit, get ourselves a little bit different view. Move this over. Now, if say there's some problems around this front portion of this building right here where these bricks are. Now, maybe you might need to explain something up in there, where it goes and how you're going to get under that soffit right there. So you've got this soffit ledge. Now that thing looks hollow on here, but in reality that'd probably have some structural members and things like that, and you can't pipe through there, so you got to go underneath it. And maybe this could be a seismic separation assembly or something like that, and you're like, well, that's not going to work. We gotta go around it, but the customer doesn't want it to look ugly, so where are we going to put that at? And so you get over here and you come in and you draw an isometric drawing, maybe from this angle right here, and then you tell them, okay, you're going to come over to it and you're going to wrap around underneath here or wherever. But you see, you can draw everything you need on one set of prints instead of 2 or 3 different views. Anyway, I hope that helps somebody. A little bit long-winded here, but I love isometrics because they save me from having to talk my brains out and then finally get in the truck and drive over somewhere and, walk to it and show somebody, especially if you get out in places like paper mills, sawmills, coal mills, things like that, where they have conveyors and stuff like that, that you might have to walk a mile up a conveyor to get there. And if you got to walk up there one time and then measure it all out and then turn around and walk a mile back, you draw it up, you get all the parts and stuff up there, and then the guys have to carry the parts a mile up the conveyor, and they get up there and can't figure it out, then you got to walk a mile up the conveyor and talk to them. And I mean, that takes a long time, and literally there are conveyors that go for miles, and it's just one little way in and one little way out. And if you can do the isometrics, it can save you a lot of headaches. And that's what actually got me to start doing that, is because I was making so many footsteps every day trying to explain to somebody what I wanted when I was really needed to be somewhere else. So clarity in blueprints, and every construction professional should know how to do an isometric drawing, and I think it's most important to learn how to draw them from this angle right here, floor level. Anyway, hope that helps y'all, and I know it will if you pay attention. Thank you very much.